Now, students, let us start with exercise 14.5. Before I start the exercise, let us see what is addition theorem. So, first of all, let us see what is addition theorem for two or more events. Addition theorem. So, addition theorem is if A and B are any two events, if A and B are any two events associated with a random experiment, associated with a random experiment, then P A or B, P of A or B is equal to P of A plus P of B minus P of A and B, or in set language, or in set theory language, we can write P of A union B is equal to P of A plus P of B minus P of A intersection B. So P of A union B equals to P of A plus P of B minus P of A intersection B. And students, if the events are mutually exclusive, then P of A intersection B is phi. If A and B are mutually exclusive events, then P of A intersection B is equal to phi. In that case, we have P of A union B is equal to P of A plus P of B. Now, when events are not mutually exclusive, then P of A union B is equal to P of A plus P of B minus P of A intersection B. Right? Then for three events, next is if A, B and C are three events. If A, B, C are three events associated with a random experiment, then P of A union B union C, this is equal to P of A plus P of B plus P of C minus of P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B and intersection C. So this is the theorem for three events. Now the next theorem is P of A intersection B bar. P of A intersection B bar, this is equal to P of A minus P of A intersection B. Now students, as we have studied in the chapter sets, A minus B and B minus A. So this region is, and there are two regions, one is this one. So this is either A minus B, or we can say A intersection B bar, and this is the region B minus A or A bar intersection B. This region is A bar. A bar intersection B. Now students, we know that A minus B is equal to P of A minus B is equal to, we have studied in the chapter set, N of A minus B. This is equal to N of A. This is set A and this is set B. And अगर हमने A माइनस बी फाइंड करना है तो हमने क्या किया था उसमें, N of A माइनस N of A इंटरसेक्शन B. और अगर हमने B माइनस A निकालना है, आई राइट ओवर हेयर, हमने सेट्स में किया था N of A माइनस B इज इक्वल टू N of A माइनस N of A इंटरसेक्शन B, and N of B minus A is equal to N of B minus N of A intersection B. So same over here. So A intersection B bar is equal to P of A minus P of A intersection B, and P of A bar intersection B. This is equal to B minus A. So this is equal to P of B minus P of A intersection B. So same point is to be used over here. Then we have students P of A bar intersection B bar. This is equal to 1 minus P of A union B, and P of A bar union B bar. This is equal to 1 minus P of A intersection B. Right students, so these are the points which we use in the questions of exercise 14.5. Now let us start the exercise. Now very first question students, A and B are the events in a sample space S such that P of A is 0.4, P of B is 0.5, and P of A union B, this is equal to 0.6. So find out P of A intersection B. This is to be find out. So apply the formula students, that P of A union B is equal to P of A, P of B minus P of A intersection B. So this is 0.6, P of A is 0.4, 0.5 minus P of A intersection B. So 0.6 is equal to 0.9 minus P of A intersection B. So therefore 0.6 minus 0.9 minus of P A intersection B. So minus 0.3. So therefore P of A intersection B is equals to 0.3. So students, this is the answer of first part. Right. Now second question. Now in the second question we are given that P of B, P of B is 0.69, P of A is 0.54, and P of A intersection B, this is equal to 0.35. So we have to find out, number first part is find out P of A union B. So this is equal to students P of A, P of B minus P of A intersection B. So P of A is 0.69, 0.54 minus 0.35. So 1.53 minus 0. Sorry, 1.23 minus 0.35. So solving it, we get answer is 0.88. So this is the answer. Now the second part. Second part is P of A bar intersection B bar. So this is equal to 1 minus P of A union B, and value of A union B in the first part This is 0.88. So this is equal to 0.12. So P of A bar intersection B bar is 0.12. And then the third part is P of A intersection B bar. So P of A intersection B bar, this is equal to P of A minus P of A intersection B. P of A is 0.54 and A intersection B is 0.35. So we get 0.19. Right, students? The answer is 0.19. Then the fourth part P of B intersection A bar. So this is equal to P of B minus P of A intersection B. So P of B is 0.69 minus 0.35. So we get 0.34. So students, this is the fourth part. So I hope all these parts are clear to you, students. Now students, let us see the third question. Now the third question is, if A and B are the events in a sample space as such that P of A is equal to 3 upon 4, P of B is equal to 5 upon 8, and P of A intersection B, this is equal to 1 upon 2. So find out, number 1, find out P of A bar union B bar. This is to be find out. So this is equal to 1 minus P of A intersection B. The formula for P of A bar union B bar equal to 1 minus P of A intersection B, and this is 1 minus half. This is equal to half. So answer is 1 by 2. And second part is P of A bar intersection B bar. So this is equal to 1 minus P of A union B and 1 minus P of A plus P of B minus P of A intersection B. So 1 minus P of A, 3 by 4, PB is 5 by 8, and minus 1 by 2. So LCM is 8. We get 6 plus 5 minus 4. We get 1 minus 7 by 8. So we get answer is 1 by 8. So P of A bar intersection B bar equals to 1 upon 8. Now sum number 4, students. Let us see sum number 4. The probabilities of occurrence of two events A and B are 0.25 and 0.50. So here P of A is 0.25, probability of occurrence of A, and probability of occurrence of B is 0.50. The probability of their simultaneous occurrence. So it means P of A intersection B is equal to 0.14. Find the probability that neither A nor B. So it means A bar intersection B bar. We have to find out P of A bar intersection B bar, and this is equal to 1 minus P of A union B, and this is equal to P of A plus P of B minus P of A intersection B. So this is equal to P of A 0.25, 0.50 minus 0.14. So we get 0.75 minus 0.14. So what we get? 0.61. 1 minus 0.61 is equal to 0.39. So this is the probability that neither A or nor B occurs. Now sum number 5. Let us start with sum 5. One card is drawn from a pack of 52 cards. Find the probability that it is either a face card or a red card. Find the probability that either a face card, either a face card or a red card, either a face card or a red card. Now, students, we know we have uh, 12 face cards. So we have 12 face cards. So probability that it is a face card, this is 12.52. Now, students, in the question, we have to see that either the events are mutually exclusive or not. Now, here we can see that in face card and red cards, few cards are common. And when cards are common, then events are not mutually exclusive. So, here face cards are 12, red card are 26 upon 52, and uh, common cards between face cards and red cards, there are 6 card common. So we write 6 upon 52. So on adding this, we get 38 minus 6 upon 52. We get 32 upon 52. So 4 8 is 8 by 13. So either a face card or a red card, the probability is 8 by 13. Second part is neither a face card nor a red card, and this is equal to either a face card or a red card. So this is P of A union B. Now second part is neither a face card, neither a face card nor a red card. So it means this is equal to P of A bar intersection B bar, neither a face card nor a red card, and this is equal to 1 minus P of A union B, and A union B, this is equal to 8 by 13 from the first part, and solving it we get 5 by 13. So probability that neither a face card nor a red card equals to 5 upon 13. Right, students? Now some number 6. One card is drawn from a pack of 52 cards, each of 52 cards being equally likely to be drawn. Find the probability that card drawn is red. Card drawn is red. Now we have 26 red cards. So therefore probability of drawing a red card is equal to 26 upon 52. This is equal to 1 by 2. And probability that card drawn is a king. Card drawn is a king. Now we have 4 kings. So 4 upon 52. This is equal to 1 by 13. And third part is card drawn is either red or a king. Either red or a king. Now students, we have 26 red cards, 26 upon 52, and we have 4 kings, 4 upon 52. Now common cards between red and king. There are 2 cards common between red and king. So this is 2 upon 52. So we get 28 upon 52, and on simplifying it, we get 7 by 13. So students, this is the sixth question. Now the seventh, a die is thrown. Find the probability of getting a number which is multiple of 2 or 3. Probability that a number is, first of all, we write like this. When a die is thrown, then sample space is 1, 2, 3, 4, 5, 6. Let A is the event that A is the event that number is multiple of 2, number is multiple of 2, and B is the event that number is multiple of 3, number is multiple of 3. So students, P of A number is multiple of 2. Now 1 to 6 case में, if there are numbers from 1 to 6, then multiple of 2 will be, there will be 3 cases, 2, 4 and 6. 3 upon 6. The cases will be 2, 4 and 6. These are the multiple of 2, 2, 4 and 6. So these are 3 cases. So probability will be 3, 3 by 6. And P of B, multiple of 3, these are 2, means 3 and 6. And P of A intersection B, P of A intersection B, this is equal to, now uh, we will take that number which is divisible by both 2 and 3. So that number is 6. So what we do, take LCM of, take LCM of 2 and 3. This is equal to 6. So multiple of 6 will be only 1, that is 6, right? So P of A intersection B is 1 by 6. First we find multiple of 2, then we find multiple of 3, and then we find common, that number which is divisible by both 2 and 3, and that number is only 6. So it means only one number is there, so we write 1 by 6. So probability that number is multiple of 2 or 3, probability that number is multiple of 2 or 3. So this is equal to P of A plus P of B minus P of A intersection B. So this is 3 upon 6 plus 2 upon 6 minus 1 upon 6. So we get 4 by 6, and on simplifying it we get 2 upon 3. Now the next question, students. Next question is, uh, one number is drawn from numbers 1 to 100. What is the probability that it is divisible by 4 or 6? So numbers हमारे पास कितने हैं? 1 to 100. 1 to 100, right? A event that number is divisible by, event that number is divisible by 4. B is the event that number is divisible by 6. So P of A number is divisible by 4. So 1 से 100 के बीच में अगर हमने नंबर्स फाइंड करने हैं विच आर divisible by 4, so these are 25. 25 by 100. P of A equal to 25 by 100. What we do, divide 100 by 4, so we get quotient as 25. So there are 25 numbers which are divisible by 4 between 1 to 100. Now P of B. P of B means probability that number is divisible by 6. So 1 to 100 के बीच में numbers which are divisible by 6. So these are 16. 16 upon 100. What we do, divide 100 by 6, we get 16 as quotient. So 16 is the number which are, there are 16 numbers which are divisible by 6 between 1 to 100. Now P of A intersection B. Now we have to find out those numbers between 1 to 100 which are divisible by 4 and 6 both. So take LCM. The best way is LCM of 4 and 6 is 12, and multiple of 12. Multiple of 12 between 1 to 100 is 8. 8 by 100. Divide 100 by 12. We get 8 as quotient. So 8, there are 8 multiples of 12 between 1 to 100. So students, there are 25 multiples of 4. There are 16 multiple of 6 between 1 to 100. And there are 8 multiple of 12 between 4 and 6. So required probability that number is divisible by 4 or 6. Probability that number is divisible by 4 or 6. This is equal to P of A plus P of B minus P of A intersection B. 25 by 100 plus 16 by 100 16 by 100 minus 8 by 100. So we get 41 minus 8 upon 100, and this is equal to 33 upon 100. So answer is 33 upon 100. Now sum number 9, students. Let us see number 9 question. A die is thrown twice. What is the probability that at least one of the two throws comes up with number 4? So at least one of two throws, comes up with number 4. Right, students? So here number of favorable cases, these are equal to, so we can write 4 1, 4 2, 4 3, 4 4, 4 5, and 4 6, or 1 4, 2 4, 3 4, 5 4, and 6 4. So these are 11. So number of favorable cases are 11, and total cases will be 36. So required probability is equal to 11 upon 36. So probability that at least one of two throws comes up with number 4 equal to 11 upon 36. इसका मीनिंग ये होता है कि हमारे पास 4 जो है वो किसी भी थ्रो में आ सकता है. Now here 4 is coming in first throw, 4 4 4. Now 4 is coming in first throw, and here 4 is coming in the second throw. 4 is coming in second throw, and here 4 is coming in both the throws because he says at least one of the two throws. So जो 4 है वो दोनों throws में भी आ सकता है. So these are 11 in cases. So probability will be 11 upon 36. Now students, the 10th question. A coin and a dice are thrown. Now students, when a coin and die are thrown, then the sample space will be H1, H2, H3, H4, H5, and H6, T1, T2, T3, T4, T5, and T6. So first part is a head or even number. A head or even number. Now students, a head or even number. So here the cases will be, how many cases will be there? Head, H1, H2, H3, H4, H5, H6. Head or even number. Even number means head or even number, T4, T2, T4, T6. So head means H1 to H6, or even number. So even number may be T2, T4, and T6. So here the cases which are in favor, these are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and total cases are 12. So probability will be 3 by 4. Right, students? And second part is a tail or odd number. A tail or odd number. So here tail. So we write all the cases having tail, T1, T2, T3, T4, T5, and T6, and odd number. Odd number में हमारा आएगा H1, H3, and H5. So again these are 9 numbers, 9 cases. So we have 9 cases which are in favor, and total cases are 12. So this is equal to 3 by 4. Right, students? Now students, the remaining question will be discussed in the next video. Thank you.